This video is going to cover the 1.5 warm-up, but it's going to give you time to work on it. So you can hit play and leave play. You don't need to pause it. In about 10 minutes, it's going to resume, and then I'll go over the solutions to the warm-up. All right, now we're ready to go over the solutions to this warm-up. So hopefully you had the time to finish it or get close so that when you're going over it, you're checking your own work. Feel free to make any corrections on this because remember, you're going to submit it at the end. So this one says, given f of x is 3x minus 1 and g of x is x squared minus 4, find the following and include the domain restrictions. So after we do the combined functions, we're going to find the domain restrictions. But remember, if it's a combined function, like if it was an f of g of x, we would need to carry down the domain from that g of x, even in our composite. All right, so number one says f plus g of x. F of x is 3x minus 1. G of x is x squared minus 4. And I'd get x squared plus 3x minus 5. So based on this, there's no domain restriction because there's no variable in the denominator and no variable under a root. So my domain would be negative infinity to positive infinity. Now, because I can wait till the combined to plug in a value, that's my domain. But I can also plug in a value at the beginning, which means whichever domain restrictions were here would carry down. There's still no restrictions because this is all real numbers and this is all real numbers. But if there were, and then I used that function later, I would also need to take that restriction into consideration when I'm coming up with the domain restriction for the whole thing. Number 2 says f minus g of x. So now we're doing f, which is 3x minus 1, minus g, which is x squared minus 4. This minus is going to go to both. 3x minus 1 minus x squared plus 4. And you can rearrange that, negative x squared plus 3x plus 3. And the domain on that, negative infinity to positive infinity. Now we go to 3, f over g of x. F is 3x minus 1. G of x is x squared minus 4. There's not a way to simplify this, but what happens in our domain restriction is we've now put that variable in the denominator. So you can say that this cannot equal 0, and you could have either factored it because it's the difference of two squares and said x can't equal negative 2 or positive 2, or you could have moved the 4 over, so x squared could not equal 4, square root, making sure to put that plus and minus, and x cannot equal plus or minus 2. So either way, you get the same domain. X cannot equal negative 2 or positive 2. And in interval notation, that goes negative infinity to negative 2, union negative 2 to positive 2, and then 2 to positive infinity, because it's all the numbers less than negative 2, all the numbers in between negative 2 and 2, and then all the numbers bigger than 2. 4 is f of g of negative 1. So we're going to start by plugging negative 1 into g. So it comes up here. I get negative 1 squared minus 4, which is 1 minus 4, negative 3. And then I want to find f of negative 3. So the negative 3 goes in here. 3 times negative 3 minus 1, negative 9 minus 1, which is negative 10. And then remember, it's just the last answer. That's the answer for the combined function, not a two-part. And last but not least, g of f of negative 2. I'm going to do f of negative 2 first. I'm going to plug that in to the f. So 3 times negative 2 minus 1, negative 6 minus 1, which is negative 7. And then I want to do g of 7. So we're building this in here. Negative 7 squared minus 4, 49 minus 4, which is 45. All right, those are the solutions for the 1-5 warm-up. You want to make sure you submit the warm-up as your classwork grade for today, and then use the remaining time to work on the 1.5 homework, which is due tomorrow morning. Have a good day, guys.